Welcome back to another video lesson. Today's lesson is 8.4. We're going to be dealing with multiple ways of showing functions, and we're going to be analyzing them. Because of that, I want you to fill out your table of contents on page 83 is where I am. I'm titling it Analyzing Functions because that's the newest part of this lesson. And then you can take your foldable and fold it like a book and stick it into page 83. And I just want to review the different ways that we can describe a relationship between two numbers. That's basically what a function is. We can talk about it with words. We can also write an equation. We saw that. We also can show different relationships between numbers in a table form. And we also can show it as a picture, and we can graph those as coordinate points. Why bother showing functions all different ways? Well, the reason why is the crux of the new part of today is we're going to analyze the relationship between the two numbers and the two quantities. So I want you to fill in that word analyze, and then we'll do an example. We'll talk through that example below. So here's an example of a relationship describing with words only. So we have a runner's distance in a marathon being equal to 8 miles per hour times the number of hours. This could work for any kind of situation. Say the runner runs for 1 hour. Say the runner runs for 10 hours. We can see this relationship and find the distance related to how many hours he's out running or she's out running. So if we wanted to describe this situation in an equation, it would be the distance d is equal to, that would be the equal sign, 8 miles per hour. So the per, you can circle that, and the hour is multiplying by that. T could stand for time in this case, as far as the variables are concerned. We also then can track in a table form how long this runner is running for and how far, the d, the distance that runner is running in a table. And then finally you see over here, it plotted out in ordered pairs so that we can see the picture of what's happening as this person is running, how far are they going. The big idea, again, is the analyzing part. And this is an example of something that you can write if you were asked to analyze this situation. And one thing to always point out is that this graph ends up being a straight line, a linear line. And so that's why I have that underlined. The graph is linear because, and then this is what we're going to work on today, describing the relationship. And the relationship is for each hour that that person runs, the distance increases 8 miles each hour. Now we're going to go on to the inside of your book. So open that up. We're at the first box. We're first going to jump from going from the word situation to an equation. And I'm going to give you some steps for that. The first thing you have to do when you're wanting to write an equation from the words is define your variables. Figure out what your letters will be. And they will be related to the topics that are in the situation that the words describe. Sometimes they're going to be given for you, so that kind of takes the thinking out of things, but it's important to make sure you know what your variables are and what they stand for. Then, the second piece is a very important mental question that you have to ask yourself. You have to figure out which one is dependent on the other, and that will tell you which one goes in the Y spot and which one is the X spot in your table and in your equation. And then after, we will write the equation. So here's a situation describing a relationship, that's a function, with words. The drama club is holding a bake sale. They are charging $5 for each pie they sell. Write an equation to find the total amount earned, T, for selling P pies. So you notice they're giving us letters. So first thing we have to figure out, okay, what do these letters mean? T, and I want you to write it out, is the total. They tell us that in the paragraph, so we're just going to remind ourselves the T is for total, the P is for the number of pies, or just pies, that they sell. So the first thing we have to ask ourselves is which one is dependent on the other? Is the total dependent on the pies, or is the pies dependent on the total? So according to dependent and independent variables, one will affect the other. Will the total affect the number of pies being sold? Not really, because if you have one pie for $5, the $5 is how much it costs. So you have to think, okay, if I have 2 pies, it's going to increase the total. So the pies are independent and the total is dependent upon how many pies you want to sell or buy. So we're going to mark the total with a D. That's dependent upon the pies, and we're going to label the P the independent variable. So this is very important because the dependent variable always comes first in your equation. We saw equations always starting with y equals x plus whatever. So we're going to not have x and y now, but it's still the dependent first in our equation, which is the y spot. So we're going to have our t equals as we're building this equation. Now we have to look at this keyword each. Go ahead and put a box around each and write above the sign for the multiplication. That's multiplying. So we have 5 times the number of pies that you have. That will be your right-hand side of your equation, your independent part. So no matter what many pies you have or you sell, the total is going to depend on that number. And we have our equation. Let's do another example. Here's the word situation. A mouse can travel 8 miles per hour. Write an equation to find the total distance D a mouse can travel in H hours. So first we're defining these variables. D is for distance and H is for hours. Now we have to figure out which one is dependent upon the other. Is the distance dependent on how many hours that little mouse runs, or is the hours dependent on the distance? Hopefully, when you're thinking about it, the only one that makes sense is that depending on how many hours you run, that determines how far you go. So the D is going to be the dependent variable, and the H is going to be the independent variable. Now we look up here, it's 8 miles per hour. So per hour, we're going to multiply the 8 times the H, which is the independent variable, and that is going to equal the dependent variable, the distance. So this is the equation that makes sense. Doesn't make sense to switch the variables around because the hours is needing to be multiplied by that 8 in order to find the distance. You try this one on your own, and then I'll come back and show you what I did to solve it. Define variables, think about dependent and independent variables, label which one is which, and then try to write an equation. Okay, so what I have here is I've defined the 2 variables that we're working with. Cookies is C, H is hours, and then I've underlined the key sentence. 36 cookies each hour. Each is our key word that we've been seeing often for these examples, and that means multiply. And we have to label which variable is dependent upon the other. Again, depending on how long you bake will determine how many cookies you have at the end. So the independent variable is the hours, and the dependent variable are those cookies. Because of that, we're going to have our C being equal to the 36 that's going to be multiplied by the number of hours that Risa bakes. Now that we have practiced taking a situation and coming up with our own equation for it, we're going to do one more example that we're going to use all the types of representations of functions. We're going to start off with the words. We're going to come up with an equation. make a table, graph it, and analyze it. So here we go. A school is selling tickets to a football game as a fundraiser. Each ticket costs $3. That sentence is important. Let's underline it. And here are the directions. We're going to write a function rule, that's the equation, to find the total cost of the X tickets, then graph and analyze the function. So I have the first part here. I'm going to actually change my screen down to the table so that we can plug in our information. So the key sentence in that situation is that each ticket costs $3. So we need to figure out the variables going on here. We have tickets and we have dollars. One is dependent upon the other. So you can write it over on the left. I'm going to go up here so that you can see it as well. Two situations we're dealing with are the tickets. So that's going to easily be tickets, T, and the cost, which is money, dollars. You could use a D or a C, doesn't matter. But I want to define these variables so that I can think about which one is dependent upon the other, so that I know which one to put in what column. So this is a very important question, this whole question of dependent and independent variables. Are the number of tickets dependent on the cost, or is the cost dependent on the number of tickets? That's what I'm asking myself. I'm just switching the order of those variables around and using the phrase, which one is dependent upon the other? So again, are the tickets dependent on the cost, or is the cost dependent on the tickets? And the only one that makes sense is that the cost is dependent and determined by how many tickets you have. So I'm going to write the word cost on my output or dependent variable side, and I'm going to write tickets on my input or independent column. So tickets are dependent, cost is independent. Now we have to come up with a function rule or a pattern. So our equation is going to start with D equals 3C. The pattern is just this 3C. But because I'm going to be dealing with X's and Y's, I'm going to change my C to an X. If that's confusing you, the only reason why is that when we're dealing with a graph, we deal with X and Y values. You'll see our graph later on. We're going to label the axes, the x-axis and the y-axis, to mean tickets and cost. So it should make sense at the end, but I'm just making this transition from the topics to the x and y's so that I can get my coordinate points. So our rule is 3x. Now we get to plug in any numbers we want, just like when we were making our own tables. So I'm going to start off with 1 ticket, 2 tickets, and then 3 tickets. In the center, I'm going to pluck and flop. This is not new. And then I multiply across to get my y values of 3, 6, and 9. Now I'm going to stick my x numbers and my y numbers together going across. So this coordinate point is 1, 3. The second one is 2, 6. And the third point is 3, 9. Just again, taking the number from the y spot in the x column and putting them in an ordered paired way. I'm going to switch out my screen. You're just going to go down to the graph. Okay, so remember when I said we're going to switch out these variables, that's because this axis right here is the x-axis, but it's going to stand for our original topic. It's going to stand for the tickets. So I want you to label this axis the topic of that T, that tickets. Similarly, the dependent variable, the cost, is the y value. So we're going to label this axis cost. Now we're going to plot our points. First point was 1, 3. So we're going to need a dot at 1, 3. And then it's 2, 6. And then 3, 9. Make sure you have a straight edge and draw a line through those 3 points. So you just want to draw a line through the 3 points. You don't need to extend it all the way down to 0, 0, even though if you were to plug 0 into the rule, you would get 0. And if we were to extend this, it would go down to 0, but that's okay. Just draw a line through what we have. And now this is the newest part. Now instead of just stopping at the graph, we're actually going to take a moment and compare and look at what's happening to this graph as the tickets are increasing. So down here, we're going to be comparing what happens to the dependent variable as the independent variable is increasing. So we're going to look at what's happening to this line as the tickets increase. Is it going up or is it going down? If it's going up, then the cost is increasing. If the line is physically going down, it's going to be decreasing. To start off our analysis, we can always begin with saying, hey, the cool thing that happens is that it's in a straight line. And that's the verbiage of linear. So we're going to use the word linear. The graph is linear. Linear means straight because. And when we look at the one ticket, it's at a 3. We move over a ticket and it jumps to 6. We move over another ticket, it jumps up to 9. So we're looking at what are the jumps. Each jump is increasing by that price of the ticket, the $3. So we're going to say that in our analysis. We're using the topics of tickets and cost as well. The cost, what does it do? Increase or decrease? Increases by how much each time? So we're going to increase $3 for each ticket that you buy or purchased. The newest part is talking about the graph after we actually create the graph. So we're going to analyze tomorrow and we're going to practice how to talk about the graphs. If you could, just initial the bottom of this page to sign off on the fact that you're done for the night, and I'll see you tomorrow. Have a great night.